Now with us, Dr. Bafil Kravchenko is going to speak about financial internet, what, when, and why. Dr. Bafil, welcome and start.
Hello.
Hello, Dr. Bafil, hearing me? Dr. Bafil?
Yes, do you hear me well?
Greetings for you first.
Thank you.
Dr. Bafil Kravchenko is going to speak about financial internet, what, when, and why. Dr. Bafil, welcome and start.
Hello, everyone. I want today to talk about very interesting topic that relates to the future financial world. So it's let me present. Are you able to make me a presenter? I want to share my screen because now it's disabled. Fatma, let me check. Right, okay. Thank you. Let me do like that. Great. Okay, so my background is information security and cryptography in general. So I was building secure systems. I also a developer. I used to be iOS and Android developer like 10 years ago. And my main specialty was banking applications. So I participated in creation of the biggest mobile application for the biggest bank in the Netherlands, some banks in Germany, now in UAE. So that's like my experience in development. I joined blockchain sphere in 2014 when I was in the US, and I was a cryptographer at Stellar. Then I worked in Singapore as a cryptographer as well. So, and the same year, 2014, with my partners, we established Distributed Lab. And Distributed Lab is like an R&D center for the blockchain and decentralized projects with the aim of building financial internet, which I will talk about today. We've published quite a lot of books. Not all of them are on this screen. So one of them is the book about like blockchain. It's like technical book with many technical details. It's aimed for students, and we sell it like online. We have other books I'll explain later about the books about how to build platforms, mobile platforms, web platforms, etc. That's a bit later. First of all, why we actually decided to take financial internet as our mission. We've been, again, with my partners doing some development, IT in financial sphere and blockchain sphere. Then we realized that what's true for the internet, it's not true for the financial world. So on the internet, the data can be shared easily from a technical perspective. Email can be sent anywhere in the world for free. You can exchange information, but with financial data, like every company has its own system, luckily if it's digital, but this system cannot really communicate through external world. So you need to have a lot of people, you need to have a lot of manual interactions between people to transfer financial data, and not just transfer. You need to have people to establish trust to that particular data. So it's very inefficient. And we said, well, it seems that now, at least was with cryptocurrencies, they advocate open APIs, they advocate access to data, secure access to data, and so on and so forth. And the same principles can be applied for the like financial industry. And we started to move towards that direction, and we've taken quite a lot of projects from financial sphere, like dozens of projects. They all dealt with some assets, with money, with stocks, with loyalty, with real estate, with intellectual property rights. And we've built that projects, and kind of during this process, we've built our own product, which is the framework. It's like a set of components. I will talk about that a little bit later. So what is financial internet as we see it? It is basically when all accounting systems use the same language of communication. It's like, again, the English. As soon as you know English, you can talk to any other person. If you don't know English, you can't. So at the end, it's like TCP/IP or HTTP. You need to know, the system needs to know the language in order to exchange the data. And this language of communication, in case of financial data, should be obviously secure. So if certain data is received, we need to know from whom it's received securely, and authenticate the source of information. And we need to know the data wasn't changed during the transmission. So we need to have integrity control measures. And in certain cases, we need encryption, and so on and so forth. And in certain fancy cases, we need zero-knowledge proofs. They are very rarely used in financial industry, but in the like in crypto space, they are starting to be used. So it's not a complicated situation. It's just, again, a language of communication between accounting systems. And I personally don't care which language it will be, unless it's open, everybody can learn it, and everybody can start talking using this language. I can show you. Okay. So just an example, because we are on mobile conference. If you go to the to your Google Store or Apple Store and you search for mobile bank, that was my first page of the result. You will see many applications for banks. Could be thousands. And eventually, it seems that each bank will have its own app. That might be, most of them. And there are more than 10,000 banks worldwide, probably like 50,000 banks or so. And each of them, when they build an application, it is not compatible with another bank. So if I use Raiffeisen Bank, it's the largest Austrian bank, it won't be compatible with the largest Ukrainian bank. The app will not work. Even if I like the app, I cannot use it for any other bank. And this situation is, from one perspective, it's kind of seems okay. From another perspective, it's kind of, imagine that you are on the internet and you want to visit like 20 websites. And now each website tells you to install their own browser. So one site says, we work only with whatever, Safari. Another site says, oh, it only works in Chrome. Another in Opera and Mozilla, and so on and so forth. Each one, and you need to install all these browsers. And then what happens, interface of the websites are always different depending on which system you use. And you could be confused. So you got used to the fact that the close button is always on the right, for example, and the search is always on the top. And so you have certain patterns of behavior. And with banks, it's the same. It's actually everyone is inventing their own interface, how they display balances, history, transfers, some other features. They're all different, and you need to learn, so you cannot use it. So this is the current situation. Why this happens? Because, again, the the banks do not have open APIs, most of the banks. And even they have open APIs, these APIs are not uniform. They're all different. They speak different languages. So they need different mobile apps. Even in the European Union, where the so-called PSD2 directive is effective already, and this directive says that all banks must open their APIs, this directive doesn't say that these APIs should be the same or uniform, and they're not cryptographic. And so then developers must implement all of them or use some aggregators or so, and it's a lot of manual job, and it doesn't need to be like that. And then if you think further, then it shouldn't be that only banks have open APIs. It could be that your loyalty company that you use loyalty with has open APIs. It could be that your real estate management company has open APIs. It could be that your, again, stocks is more or less digital already, but with most of the assets, accounting systems do not have open APIs, and you cannot connect them with a single app. And that's an issue. So we said, okay, let's try to come up with systems that do implement accounting system of generic type, and they could enjoy reusability of all the modules. So you wouldn't argue that if you go and manage balances in a bank, it's not that much different from managing balances in the investment application. It's still a balance. It could be in different asset, but it's still a balance. You could still do a KYC. You can still do the transfer. You can still see the history, and all these operations are kind of independent from the type of the asset that you are dealing with. So why to reinvent so many things if they are so much alike? And that's what we started to do, and we kind of on this path. Eventually we will create, and there will be others obviously, we'll create the needed protocols and the kind of operational system for the digitized assets. And you can think about this as the WordPress or web server that deals with certain functions independently of the design and representation. So in 10-20 years, what will happen? And again, most people will not argue with that. They will argue with time frame, but not with the items. That we will have free instant payments with any bank. That's already going on. That we will not have a physical cards that are rudimentary. They are rudimentary. Why should you remember these codes and fill these numbers if it could be a digital key? We will have currencies that are issued by central banks directly and by smart contracts, algorithms. We will have predictable rules for assets, for financial assets. We will have full automation. I doubt that we will employ people that will fill documents. It's like, even if Google employs a lot of people, when email works, you don't need a person checking papers or approving something. The person could be the administrator of the system. It could be, developer, but definitely not the postman. And the payment infrastructure in general will become commodity. And then the last point, which is not obvious again, in that all transactions and all assets will be working in the same way. So without difference, whether it's money or stocks or loyalty or something else. So in the latest years, where we see a lot of blockchain projects, and I'm also from that space for the last 6 years, we see the huge demand for things that kind of digitize or automate processes. And they promise more or less the same things: the free transactions, global asset management, smart contracts, and so on and so forth. But most of them, they have certain disadvantages. First, they explain financial internet or internet of value or something like that as a global shared ledger, like Ethereum, for example. They say, oh guys, come all to our platform and put your assets on our platform and deal with them on our platform, and it's very cool and blah, 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 but pay fees in our currency. And you must have their currency to initiate any kind of transactions, which I believe is not fair. And then the people say, oh, you need to have miners, these miners need to mine, you need to have certain incentives, you do this, you do that, even if it doesn't make sense. If you run a warehouse and this warehouse stores gold or whatever, oil or gas, why would you need a decentralized, global decentralized system to manage your like warehouse receipts? You probably don't need that. You run it yourself because people, when they put oil into your warehouse, they trust you. If oil disappears, it's not that some whatever miner on the internet is responsible. It's the owner of the warehouse. So for the most of the assets that exist in the world, there's always a custodian. There's always a responsible person for that. Then some companies say, oh guys, look, we are the company that will be providing service to everybody. You have to use us. This is called monopoly, and monopolies never end well, especially if they don't provide any alternative. So you can, it's like internet is not a monopoly. That's why it's so successful. That's why it's brought so much innovation, because everybody can experiment on it. I don't need to sign up anywhere, no terms and conditions, no KYC if I want to use HTTP or email. This is the beauty of it. And it's like a language of communication. No language requires any license and approval. And that's exactly here. We're not talking about the particular software. The software might be licensed and will be open source or commercial, etc. But the language of communication should never be licensed. And again, many companies obviously don't want that because they want to fully control. And if you study history of internet, that, like for example, Microsoft in the 80s suggested that they will become, and they actually fighted for the internet to be proprietary, and they obviously failed. And yeah, but still many companies wanted internet to be subject to advertisement and to subject to payment for each request. So imagine the current world if they succeeded. So luckily it's different. And I advocate that in the financial internet should not be any native currency. So users and companies should be free to choose in which, like each two communicating parties should be free to choose in what they want to transact. And obviously they might follow local regulations, but the protocol at least should not guide them. If they in Saudi Arabia, they use one currency. If they in Ukraine, another currency. In the US, another. So it's up to them and when they say. And the last point, very important, there shouldn't be any single identity provider. Again, because for the censorship reason and for the security reason, because the bigger companies, the more threats they kind of impose on the whole infrastructure. So it must be decentralized. So again, financial internet is the language of communication plus a set of tools that enable such communication. Okay, and then basic principles is that a set of independent systems run software that's compatible. It talks the same language, and that's how the they communicate. So that's it. It's not a one system, one platform where everybody joins. It's like many companies talk to each other, like if you're familiar with mesh network. Then the second thing is more, again, in contrary to the current blockchain approach, that for each asset should be one custodian and one, management software. Then it's easier to develop, manage, control, administrate, and so on and so forth. Then, as I already said, we should have uniform APIs for the management of assets and transactions and history. And again, this is not dependent on the type of the asset. It's more like generic operations. So like example, like any door and the lock on the door. It doesn't matter whether it's door to the toilet or to the kitchen or to the warehouse. The door we got used to, it operates in the same way. You put handle down, it opens. You like put, it's closed. So, and it's very convenient. So the same principle should be in the financial internet. And then the last point is that all operations should be digitally signed. And this is needed to trust data that you see on your screen. Currently, what I see on my screen might not be the truth, might not be the information that somebody sent to me, because like hackers can change it or some errors. I don't have a proof that the information I see in my mobile banking balance is true. The only way to ensure it's true is to apply digital signature. And this is one small task that has to be done for all financial systems. That's what we also do. We provide such components that implement such features. But again, it's super important. We have a book that describes all these principles. It's available on Amazon. We'll give it to students, and where we described all the principles, and we improve in this book. And this almanac that says how to build your own platform is like an extension about how we actually build a particular system that can be connected to financial internet, and that makes sense. Now I want to say a couple of words about how it's all connected to blockchain, and a little bit about cryptocurrencies and why they were so important for this understanding. So first of all, blockchain is a method of storage and synchronization of data between parties who do not trust each other. And depending on how strong they trust or don't trust each other, you need different types of blockchains. You probably heard about the public blockchains or private blockchains or permissionless, and very often people arguing that these are better or that are better, and so on and so forth. And this discussion doesn't make sense too much, because it all depends on where you apply blockchain. If you build a system where 10 parties communicate, like 10 banks, and they run a payment system reconciliation system between themselves, that will be a private permission blockchain. It's fine, it should be like that. If you run anonymous system with unlimited amount of participants where nobody knows, again, nobody trusts each other, like Bitcoin, you use another type of consensus algorithms, and so on and so forth. But the general idea is that first of all, all the transactions, the changes of the system are ordered, are cryptographically signed, are linked to each other, and block is just a group of transactions. And then these states are constantly synchronized between many parties who actually constitute the blockchain. This is it. It's definitely an innovation, but it uses kind of well-known techniques, except for the proof of work was invented actually more than 20 years ago, but then the creator of Bitcoin just assembled all the pieces so it worked as a final system. Then what's interesting, you may never use Bitcoin, for example, and you may not like it or like it, it doesn't matter, but there are certain lessons that Bitcoin showed, except that anonymous censorship-resistant currency can exist. This is needed for people who have this goal. But aside of that, if you look at Bitcoin, it is a secure accounting system that has no security administrators, no firewalls, no permission management, no physical security. And it's still, again, you cannot come to one place and steal all the Bitcoins. You need to go one by one. You need to come to all Bitcoin users and steal their keys, and that's how you steal all the Bitcoins. But there is no single server. There is no company that can be frozen and yeah, whatever. So the same approach can be applied to a normal financial industry, to banks, to securities companies, to real estate management funds. Now they spend a lot of money on security. Again, they employ security administrators, they have firewalls, permission, physical security. It's enormous amount of money. Instead of most of that, instead of 90% of this money spent, you could use cryptography. And Bitcoin has proven that it is possible. It actually works. You can rely on cryptography and open APIs while managing very kind of sensitive assets. That's what it is. And the second thing is that as soon as we talk about the company, that there was such concept of security perimeter that says that what happens outside is insecure, what happens inside the organization, inside the building must be secure. It says no flash drives, whatever, no internet, no random websites, there are a lot of policies. And right now, especially after COVID, it's no longer the case. People bring their own devices. People must work online. Directors have board meetings online. And you cannot have a security perimeter principle. It's dead. You need to use cryptography. And this is where the billions and billions of money will be spent to rebuild such systems. So that's what we do as well. Like understanding all these concepts, we build new systems that kind of fit in the new reality. But those who design the systems need to know that. Then I guess we have to speed up. So if we talk about what it means for me personally or for you to use financial internet, is that eventually you have a financial browser. It's like a normal browser for the internet. You have a financial browser, an application. This application will talk to your bank, to your investment company, to your real estate and loyalty and tickets that you've purchased. And this financial browser will aggregate all these assets. And it will be very convenient and very secure. Then you use more or less, you could use the same identifier for all systems. So you don't need to pass registration all the time because they already know you via digital signature. And then you can manage your own data, personal data. Right now, it's also a big issue when companies take a lot of data from the client, then this data is subject to like hackers, attacks, and then these companies must pay a lot of fines to the government. And they don't want that. And you can already implement a system where a user manages its own data, but then gives certain whatever parameters or checks to the company. Only those that are needed, but they are not very sensitive. And then the last point that will prevent a lot of fraud is that your financial browser, your application will store all the balances and all the transactions that you ever signed in your system with the digital signature of the company that with whom you are dealing with. And you will have proofs of all your operations. You no longer need to call them and ask for the receipt and and prove that you actually did that or didn't do that. So it will be very secure from the point of interaction between user and company. I guess I will skip that slide because too technical. Just one sentence is that interoperability between systems is also possible in a secure way, so we can actually exchange assets. You can exchange assets that belong to one company to another company in your app, and it will. You don't need to use any exchange or broker. It could be used using cryptography much easier. Yeah. So for the user, it will mean just like it's like my wallet, my financial browser or aggregator or a shop. For business, the financial internet software means that it's like a CRM, a payment system, a marketing tool, and for everybody it's just a protocol, a language. These features are kind of natural if this if this reality happens, that all assets will be digital. You can use fractional ownership. So I will be able to sell a fraction of my apartment, pay with it or invest with it or something like that, because yeah, it's all ownership rights. They could be fractionalized. Full traceability of end because of digital data, because of blockchain, equal treatment, and you can barter digital assets. Now it's not possible because again, technology is just not there. It's too hard. There are no such tools, even if they are very simple. So there will be many features of financial internet that can be actually already built today. You don't like our clients, they usually build systems from scratch, digital bank from scratch, or warehouse management system, or real estate management system. So before that, they have a business, but they use paper or very outdated technology. And now they use our tech and knowledge to build a new one, and we implement all these features in their system right away. Maybe not all the features could be used today, but in the future they will be. A few words about smart contracts. This is, since it's like a hype word. Smart contract is no more than a piece of code that's implemented on many machines at the same time and bring the same result. So it is very good concept, especially when you talk about decentralized code execution, when multiple parties have to come up to the same result. And the next thing is that these systems use so-called oracles, data sources that help smart contracts to bring the same result and do it in a way that doesn't require trust to a particular company. So on the example, as you can see from the picture, the contract is very simple. It's an insurance contract. Is when a farmer grows apples, if temperature goes below 0, then the farmer should get a refund, the payment from the insurance company. And obviously, we need to know whether it's really was below 0. So a few data sources is used, like satellites and certain planes and data feeds. And if all of them are bringing data that doesn't contradict each other, then the smart contract will pay the farmer. So the money will be managed via code. That's where it goes. And that will happen in very short time. So our job, what we do. We build processing centers, like operational systems for the digitized assets. We build key management software. We build identity management software. We build mobile template for mobile applications. And we build certain reference implementation for loyalty, for tickets, for banks, for that. And then we have clients, and we white label our software for them or customize. And but all these systems that we deliver to our clients, they belong to clients, even the code base, but they share the same APIs. So later you can connect them or connect the financial browser to them. That's what slowly happens. So the wallet, as already said, it's like a browser for financial web. It stores keys, identities, manages the DNS certain, and protects history of transactions. And it looks for the user absolutely the same. So the user should not feel any difference. For them, it's still like a login and password, even if the login and password never leaves the device and it's not subject to interception. But user has the same kind of story, but much more secure. And our platform is called TokenD. You can see the website, so TokenD.io. And yeah, there is no native currency. We sell it through consulting and IT company. So it's like an Oracle database. We sell software, and then we help to integrate and customize it. And you can white label it. And this book that I've shown in the beginning, it's actually the summarization of our experience of how to build platforms. It has many items like how to manage notifications, how to manage fees and limits and administrators and this and that. And then we describe all these things in diagrams. So it is like a template, blueprint for building a platform. It's a technical documentation that says, oh, if you need to implement this, you use this. And you save a lot of money on product managers and architects because we already, again, have done that. So that's how we save money to our clients while reducing the time to market and risks and budgets to deliver such systems. So this is what we do. And again, why we do that? Because you cannot build an internet or financial internet just in one click. You need to build many, many systems, and then with the idea how they will communicate. This slide probably will need for now. Oh. I think I should save some time for questions. So let's now, I will share the presentation, so no worries if you need slides, but I'm ready to take some questions. But maybe you had some questions in some private chats or something like that.
Thank you so much, Dr. Pavel,
for
sharing your experience about financial internet. My name is Akhil. I am the host for this show, for this session. Anybody have any questions? They can unmute themselves and ask the questions.
Or use the chat.
Sir, if you receive any chat, you can unmute them, or you can answer the questions directly. Sir.
Okay, just in case, soon I will be in Dubai. We have a representative office there. We have a lot of projects in UAE, and we'll have projects in Saudi Arabia as well. So we'll be happy to meet in person in some nearest time, as soon as countries open. But yeah, we work quite closely with that region also with Kuwait, and have dozens of projects worldwide in general. Okay.
Thank you so much once again, sir. It was a nice experience. This session is streamed live as well as recorded. You can, if any participants or any attendees who want to view this later, we can visit our exhibition and we can attend or listen to the speech again.
Okay, great. Then I should probably leave and you continue.
Thank you for all the attendees for attending this session. Our next session will start after 15 minutes. Thank you once again, sir, Dr. Pavel.
Yeah.
Okay,
Have a good day, everybody. Thanks for listening.